grade 9 review of solving linear equations. It's been a while. But at least equation solving for a lot of us in here was like kind of fun, in the sense that like when you finish solving an equation, you can go and check your answer. Yeah? And if you know what I'm talking about, you're like, yeah, I know what's going on here. And you'd be able to just know whether or not you got that answer right or wrong. And if you're handing in something to me, then you just have that much more confidence. You're like, yeah, I got all those equations, I got them all right, and I know I did. All right. Does anyone remember the difference between an equation and an expression? And that's a weird question, and we talked about it a little bit in grade 9. Oh, yeah? Yeah, exactly. So when I say polynomial just means like there's a whole bunch of numbers. Poly, like many. Nomial, kind of about numbers or terms or anything like that. So we have an expression and an equation. The equation, it's almost got the word equal in it. And an equation has an equal sign within it, yes? An expression would not. So like an expression would be like, I don't know, 3x plus 2y minus 4.
Oh. Sorry for the interruption. Could the following teachers and their classes please go to the cafeteria now?
No,
Mr. Chisholm, Ms. Custodio, Mr. Webster, Mr. I. Kelly, Mrs. Hammond Smith, Mrs. Oliveri, please go to the cafeteria now.
Okay. So something like that. Then the biggest difference between these two is that the equation has the equal sign. That's it. That's literally it. Now, when we solve equations, I noticed when I was coming around this morning, people were already solving the equations in the homework, and that's great. There's a couple of things that we have to remember, and you might remember from grade 9. The first thing, whatever you do to one side of the equation, you do to the other. It's all about balance. That's number one. And number two, the reason why you would want to do one thing to the one side and you have to do it to the other, the reason why you'd want to is because the whole goal here is to isolate the variable. And what that means is you want to get the x all alone on one side of the equation, right? Does that sound familiar? You got some nods? Okay. So let's talk about operations. Like addition, subtraction, multiplication, division. Remember those? These are the operations. Actually, in my grade 9 class yesterday, we were reviewing the order of operations, right? The order in which you do them, which is like BEDMAS. And for them, they're like, whoa, what is that, right? 2 years online, right? Grade 7 and 8. They come into grade 9, they're like, what is a number? These poor guys. And then an inverse operation. Okay, inverse is kind of a weird word, but how about opposite? That probably sounds a little bit more familiar. The opposite operation. So, for example, like the opposite operation of addition is, right, subtraction. The opposite of subtraction, by that kind of logic, would have to be addition, right? So if we wanted to get rid of minus 5, we'd have to add 5. Okay? If we wanted to get rid of plus 5, we'd have to minus 5. How about multiplication? What's the opposite of multiplying? Right, dividing. And by that logic, the opposite of division is just multiplication. And at some point, these aren't the only operations. I mean, there's tons of cool stuff. Like, remember, how about squaring? Remember the Pythagorean theorem? You end up with like something like c squared equals 25. It's like, is the answer 25? No, we have to do something to the square, like the c squared, to get rid of the square. You remember the opposite of squaring? Yeah, what do you think? Yeah, that's right. Yeah, square rooting. Is that even a word? Square root. That's really thinking back. I think you do like one day on the Pythagorean theorem in grade 9, yeah. Okay, so equation solving, it's all about doing the same thing to each side of the equation, and you're able to check your work. Got it. Okay. There's tons of different methods to solve equations based on what the equation kind of consists of. A lot of them have this thing called collecting like terms. Yeah, do you remember that? The like terms. There's like variable terms like 3x and like negative 2x. those are like terms because they're the x terms. And we also have these other terms without variables. Do you remember what they're called? Like how about like a +4 or -1? When terms don't have variables, they're called constants. I don't know why. We just call them constant terms. So we have variable terms, or maybe the x terms. We have constant terms. There's also terms with like, I mean, we won't really get into this, but like, for example, like 3x squared and 5x squared, they are like their own like terms. And they're unlike, they're not the same as these guys over here. But we won't really get into that. You know, as long as we understand the difference between 3x, -2x, they're good. Constant terms, they're like terms, then we're going to be all good here. So, how about this one here? This is actually starting off midway through your grade 9 equation solving experience. You notice this is an equation because there is an equal sign here. That equal sign tells us that it's an equation, and it looks like the variable we're solving for is x. 1, because it kind of tells us that, and they want us to check our answer. Now, if you're a steps person, these steps might be really helpful for you. You might want to highlight them if that's your style. Put others in here. You might just want to see the process and understand it a little bit, and once you understand the steps, then you are just rolling. So, we have your 5x minus 4 equals 3x plus 12. The goal here is to collect all the x's on one side and then all the non-x's on the other side. So when I say side, what I'm referring to is this equal sign, yeah? X's all on this side, equal sign, and then all the numbers over there. Do you remember me or Mr. Todd saying variable equals number, right? We said that like nonstop for equation solving. So if you notice, if we have, I'm gonna write that up here, variable equal and then number. When I go through an equation, I look and we see 5x minus 4 equals 3x plus 12. The first thing I notice is that this minus 4 is on the variable side. So it needs to go. It's not allowed to be there. So how do we get rid of minus 4? What's the inverse of minus 4? Oh, so she's already got the shortcut in her head. She's saying, move it over to the other side and then it'll change its operation. I 1000% agree. But before we start using those shortcuts, why can we appreciate that shortcut so much? Why do you think that? That's right. And what's going to happen, the end result, you already know this, is that it's going to end up just being plus 4 on the other side. So we're going to add 4 to the left, and that means we'll also have to add 4 to the right. Now, when we add 4 to the right, we can't add 4 to the 3x because they're not like terms, right? This is a variable term, and the 12 is a constant term. So when we add 4 to each side, plus 4 minus 4 cancels out. It's gone. So if this is my equal sign in the middle, on the left side, all we're left with is just 5x. And on the right side, we're left with 3x plus, what's 12 plus 4? 16. Good. Now, what really happened there? Yeah, if you want to use the shortcut where you say, take the minus 4, bring it over here, it becomes plus 4, yes, that is just as good. And for some of us in here, we probably have never seen that in your life. Who's never seen that trick before? Okay, if you want to use that trick, we're totally good to use it. Can I get some nods or some shakes? You know, like, can we just bring it over to the other side and, okay. And maybe for this one, we'll just do it the long way and then moving on, we'll just make it simple. 3x. 3x is on the number side. How do we get rid of a positive 3x? How do we get rid of that? We want it gone. It's not allowed on the right side, so we have to get rid of it. I see. Can't actually divide by 3 just yet. That would be the last step. Because when we're dealing with equation solving, we're actually going through BEDMAS, but backwards. Yeah? We call it SAMDEB. So subtraction addition is what we're doing first. Like equation solving is kind of like undoing BEDMAS. So the first thing we have to do is get rid of this subtraction addition. This is really, I know it's not there, but it's really a plus 3x. So if we want to get rid of that and not have it on the number side, we're actually going to minus 3x. And if we do that to one side of the equal sign, we have to do that to the other side of the equal sign. Plus 3x minus 3x will cancel each other out. We're left with 2x equals 16. Notice how there's no more adding and subtracting? There's no more of that. So we can say, okay, we're good. Next, we look at the multiplication and division, and we see here that this 2 is actually multiplying by that x. So how do we get rid of that multiplying 2? That's right. We're going to have to divide this by 2, and whatever we do to one side, we have to do to the other side. The 2's cancel. We get x equals 16 over 2 is just 8. Okay, now that's our answer, 8. They want us to check our solution. So, we can write here, let's check x equals 8. What we do is we write down our equation. Our original equation was 5x minus, why am I floating around here? 5x minus 4 equals, and I really exaggerate that equal sign, 3x plus 12. And the reason why I like to exaggerate that equal sign is because on the left side of the equal sign, I'll just call this the left side, LS. And on the right side of the equal sign, we call it RS, which doesn't stand for RuneScape. It stands for the right side. Okay. Now, what you can do, and what I think we taught you in grade 9 was draw a line right down like that. Like split the equation right down the middle. It's like Moses parts the sea. We're kind of doing that here in the equation. So we understand, like this is the left side, is the right side. Now we're just checking. So we're going to check to see whether the left side is quite literally equal to the right side. We're going to do that just by substituting x equals 8 into the equation. So 5, x minus 4. X, we said, equals 8. We go to our calculator, thinking about bed mass. Okay, 5 times 8. What is it? So in one shot, eh? Boy, 5 times 8. 40? 40 minus 4, and that's 36. Great. Love it. Now, we're hoping and praying that the right side of this equation is also 36, because if it is, then that math is totally true, and it makes sense. And we give ourselves a big check mark, because when the left side is equal to the right side, we know we've done our job correctly. So, equals 3x plus 12. 3 times 8, yeah? So we should get 24 plus 12. 24 plus 12 is 36, and we're so happy about that. A lot of people like to write this at the very bottom. LS equals RS. Give yourself a nice check mark. Say, yeah, I'm the best at equation solving. Now, this is certainly where equation solving sort of begins, but definitely not where it ends. It gets a little bit spicier, as you might know, where we have to kind of collect a little bit more. So, if we look at question B, 18 plus 3x minus 5 equals 65 minus x. Before we even start moving anything, we might notice that we have like terms already. You see the like terms there and there? So we can kind of take that positive 18 and that minus 5 and combine those terms. So we're just left with something, okay, with the 3x is still here. Why is that red? Come on. 3x. Sorry, can you read my writing? Is it like horrible? It's all right? It's legible? Okay. 3x, 18 minus 5 would just be positive 13. So I'm going to write plus 13. And on the right side, we still have that 65 minus x. Now, it's weird that it says minus x, and there's no number out front of that. But what do we know the number is out front of that x? Yeah. And listen, I've been doing math for a little while here. I always put in that 1, always. Okay, now it's very similar. It's very similar to what we've done before. Now, instead of balancing the equation, I think we agreed that we're just going to move things over. So this is the variable side on the left. This is the number side. So this number cannot be here. It's going to come on over here. Yeah? So we just have 3x equals 65 minus 1x minus 13. We've brought the 13, or now it's a minus 13. That's important to note. See how the plus 13 changed to minus 13? Yeah? That's what happens when you cross that equal sign. It changes its operation. So we can kind of tidy that up a little bit because we know 65 minus 13 would be, anyone help? I'm gonna mess up my mental math here. 52? 52? Yeah, okay. So 52 minus 1x, or maybe you wrote -1 plus 52. Either way. So this x needs to go with the other x over here. So the minus 1x will change into a plus 1x equals 52. Lovely. And here's why it's so convenient to change that negative x to negative 1x. Or now it's a positive 1x over here. Because we think to ourselves, okay, 3x plus 1x is 4x. And that just feels a little bit better to my brain. So at this point, there's no more adding or subtracting. I'm going to divide each side by 4, and x should equal 13. 13 for sure? Okay. Cool. Okay. How about this one? Very, very, very similar. You're probably already ahead of me here. Question though, do we have to collect the x's on the left always? No, no. In this sort of situation in part C, would you collect the x's on the left or on the right? And tell me why. Yeah. Oh, I see. So at some point you're going to be dividing by a negative, and sometimes that could be where you drop the ball, right? I know, yeah. I personally would collect them on the right, only because I see a negative 1x here and positive 5x there. So there's more x's on the right, so I'm going to collect them on the right. But really, does it matter? Absolutely not. You can do kind of whatever you want to do here. Also, notice how I moved the 13 first on this first one, and then I tidied it up and then moved the x, the 1x here. Who was thinking to themselves, let's just do 2 and 1? Yeah, some people in here were like, let's just move everything in one shot and then do some math. I'll show you what I mean by that. If we're going to collect the x's on the right, then that means that this negative 1x has to come over here. Agreed? Okay. And in the same move, what you might do is say that this minus 2 is going to go over here and change to a plus 2. So this is like uber shortcuts. Like this is shortcut city. So the 5x didn't move. But what came over here was the minus x. And when it crosses that equal sign, it's going to change to a plus 1x. And I'm not going to write that minus 2 because we know that that minus 2 came over to the left side with the 28. 28. And that minus 2 will change to a plus 2. Yeah? So we actually did a couple of lines of math in one line, really. So if this is my equal sign, on the right side, 5x plus 1x is 6x. And on the left side, 28 plus 2 is 30. Question, yeah?
Are you able to move the numbers so I go from the
Yeah. You probably wanted to go from here to here. Yeah. Well, here's my advice. The more steps that you don't show, the more vulnerable you become to making a minor error. Yeah. And if you do, for example, make a minor error in all of the work that's going on in your brain, The only thing that kind of hurts me as the teacher a little bit is that when I mark these things, and let's just say this was like, probably like a 3-4 mark question, yeah? It'd be hard for me to find part marks to give you, yeah? Because my job as the teacher is to try to help you out as much as I possibly can. Like when I mark things, it's not like I'm like, oh, I can't wait to take away grades. Like, no, believe me, that's not my style. I'm thinking to myself, how can I possibly give this student more marks? You know, that's what goes on in my head whenever I mark anything. But when you skip steps, it's like, oh, you know, it's kind of tough. But just between you and I, yes, you could. Yeah. Okay. Lastly, get rid of that multiplying 6 by dividing each side by 6. Should get x equals 5. And that might feel a little bit weird to write for some of us, so we might just rewrite it like that. 5 equals x, x equals 5. It's the same thing. But... Okay, I'm just noticing what I haven't done here is I haven't checked. So let's maybe check just this one over here. Let's check x equals 5. Scroll up a bit. 28 minus 1x equals 5x minus 2. 28 minus 1x equals 5x minus 2. I'm running out of room. And again, I'm going to pull out a different color here. I'm going to split the equation, write down the equal sign. I'm going to call this the left side of it. The left side of the equal sign. This is the right side of the equal sign. And again, we're checking x equals 5. So we're just going to substitute 5 into the equation for x. 28 minus 1 times 5, which is really just 28 minus 5, which is 23. Good. 5 times 5 minus 2, 25 minus 2, and 23. Oh, good. Left side equals right side. And we can have that much more confidence. If we had to hand something in, we're like, yeah, we're good. Questions about any of that? Sound like, is this familiar? Yeah. You've done it many times in the past. Unless, of course, you know, photomath works just as well for this. It really does, truly. I actually kind of endorse it because it's not one of those things that just gives you the answer. It shows you all the steps and explains the steps, you know? So I'm not mad if photomath is something that comes out to play sometimes, because sometimes seeing the answer and how it's done is how we learn. Yeah? Okay, now sometimes there's brackets. And this is actually a very nasty one because there's negatives involved. The first thing they want us to do here is to get rid of the brackets. And we do that by using this guy, pulling out a new trick, the distributive property, right? Remember that thing? It's like, if you have A and then like B plus C or something, it looks like that. I don't know, I'm just using arbitrary. We're doing A times B plus A times C, right? A times B plus A times C. And that's kind of the distributive property in a really small nutshell. So you're going to do the distributive property at some point. And you're going to collect like terms, use inverse operations, bring variables to one side, constants to the other. You're going to tidy things up. We used the terminology last year of tidying up, but really what we were doing was simplifying, collecting the like terms, isolate the variable, and then check your answer. Okay, so a lot of you might not like what I'm about to do when I take my time with the distributive property, and you might ask the question, well, can we just, and the answer is going to be yes, and you'll see what I mean. So we have these brackets here, and the first step is to get rid of them using the distributive property. So -3 times, oh, I kind of missed, -3 times positive 5, and I highly encourage you to draw in those arrows. You know, if you're working on one of these questions, you had no idea how to answer it, you draw in those arrows, I'm getting you a mark. You know, like, they're that important. So really what happens? What does this turn into? Well, we're doing -3 times positive 5, -3 times positive 5, And we're also doing, that's the first jump. The second jump is negative 3 times negative 6x. That's the second jump. And all of this is equal to 39. Some of you in here might not even write that step because you got so confident and comfortable with the distributive property last year that you're like, no, I don't need that step. And you don't have to show it. But I just wanted to show you that, this isn't coming out of nowhere. So here we go. Now we kind of simplify this. Negative 3 times positive 5, negative 15. Right? Negative times a positive, we got a negative. But here's a little bit strange, right? You got negative 3 times negative 6. So we're going to have a positive 18x equals 39. That's where the distributive property can become a little bit, nasty. Like you got to be a little careful with these things, especially when there's minuses and negatives involved, yeah? So sometimes maybe this extra step here, I shouldn't even call it an extra step, it's really a good step, but sometimes this step becomes super useful, yeah? Okay, then we go back to our roots here. Let's get rid of the constant term, bring it over here. So if this is our equal sign, we have 18x on the left all alone. We have 39 plus 15 on the right. 40 plus 15 would be 55. Take away 1. 54. You gotta help me. I hate doing mental math. I hate it. Because you mess up one thing. First of all, you look silly. Second of all, I always use one of these. Even if it's like 1 plus 2, or even though the worst one is 3 to the exponent 2. I always think in my head 6, and I'm like, no, it's 9. Did it yesterday with my grade 9s. They're like, what? Yeah. Oh, yeah, it was me too. Said the same thing. 54 divided by 18, we got 3. That's the thing about equation solving. You can mess up one little thing. It could be a negative, or it could just be like a little calculation error, and you could just look a little bit silly. Yeah. It's like I went to university with this guy. He juggled like a maniac. It was the coolest thing. Juggled 5 things. You ever see someone juggle 5 things? It looks pretty cool. Like, 2 is kind of boring. 3 looks pretty exciting. 4, it starts to turn into a carousel. And 5, it's just, it's insane. But this guy, his name was Rob. Now, we give him one more thing to juggle, the 6th thing, and he drops everything. And we were like, oh, Rob, you goof, you dropped everything. You look silly. Similar to this, like, we can have the calculator do that one extra thing while we're juggling the distributive property, double negatives, balancing the equation. We're juggling a lot of stuff here. If we can let the calculator take one of those things away, that mental math aspect of it, then we're not going to look silly. All right, and they wanted us to check here. So we're going to check x equals 3. Left side and right side, negative 3 times 5 minus 6x equals 39. So that left side is all there, and that's the right side. Now, when you're subbing into this is where different colors or maybe different types of brackets can kind of come in useful, and I'll show you why. We're going to replace this x right there, that one, with the 3. And the terms minus 6x is already in brackets. So if you're not careful in the way you write this, it could look a little weird. I'll show you what I mean. So negative 3 times 5 minus 6, and I'm pulling out another color, times 3. And then I got to close that bracket. Now, if I didn't use color there, it's going to be like bracket, and it looks a little weird. But when you differentiate the bracket, maybe you can do a small one and a large one. A lot of the times, the textbook likes to use square brackets and round brackets. But they all kind of mean the same thing. It's just to help our eyes see what's happening here. So we're going to bed math this equation. Negative 3 times 5 minus 18. Okay, negative 3, 5 minus 18. negative 13. Oh, and here we go, look at this one. Times negative 3 is positive 39. And that's what right there, that's the best reason to have a calculator. Oh, look at that, the right side's already done. Right, we don't even care. It's already 39. Woo! That felt good. Questions about anything? How do you, okay, give me a check-in. 5 is like, hurry up. 1 is like, redo that. Could I get a check-in? Show me. Okay. You're gonna hold the 1, don't hold that one. Okay. Are we gonna do both of these? How about no? How about we do the one on the right? Okay. See, or maybe you're already ahead of me in this note here, and you're already working away. Okay. So this is the reason why I want to do the one on the right as opposed to the one on the left is because, well, they both have distributive property, which we know and we can see because of the brackets. But if you look at this distributive property over here, it's not just a 2 up front of the brackets, it's a minus 2, which means that minus kind of also is negative 2. And so we got to be careful when you have a minus out front of the bracket. It's almost like last year when you were adding and subtracting polynomials. Do you remember? It was like bracket, it was like 3x plus 5, and then minus 4x minus 11, something like that. And then because it was minus, myself and Mr. Todd, we drew this face here. Do you remember that? Who remembers that little face? We're like, oh, no, it's been a while, I know. But the reason why we draw that face is because when there's a minus out front of the bracket, it gets a little weird. And it's where these little mistakes can happen. So, maybe I won't keep the box around it, but I will be very cautious. So, this is my equal sign. We got 11 equals 5x, and here we go with the distributive property. Negative 2 times 1x, so I'm going to write negative 2 times 1x, and then negative 2 times positive 7. So, we got 11 equals 5x minus 2x minus 14. Lovely. We could tidy some things up. I see some like terms right there. 3x minus 14. Isn't that great? What we can do is now bring that minus 14 to the other side, and it's going to change from a minus 14 to a plus 14. Where's my calculator? 11 plus 14 is 25 equals 3x. Divide each side by 3, and it's nasty, isn't it? Agreed? It's nasty? 8.3. 25 divided by 3, 8.3, and it repeats forever. So 8.3, and that little line over there indicates to us that that 3, in fact, does go on forever and ever and ever. Or maybe your calculator's that good and it tells you 8 1/3. You know, 8 1/3 is also just as good. Feel like that as an answer? So my calculator says when I hit that ABC button. With that button. If not, we'll get into it. Okay. Questions about that? Oh, so far so good? Okay, now these guys, I think is a little overkill. I don't think we need to go there. I really don't. And partially because of the sake of time, but also because, well, like, this very ever rarely comes up here. Okay, maybe we could just do one of them. Some of us might like to use the fractions all the way through, you know? Let's do the one on the right. You might want to distribute that all, and you know what? You could, and that would be a clever way to do it. But just like when we solved equations with fractions, what we could do, the first thing we did was we got rid of the fractions, right? That is the first thing that we did. So what you could do here is just multiply each side of that equation by the denominator, by 3. Getting some weird stares. We won't do that. We're going to distribute this as we would, like this. Okay, 5 over 3 times 2x. Now 2x as a fraction is really 2x over 1. And I'm going to write it like that because when we multiply fractions, we do numerator to numerator, multiply, denominator to denominator, plus 5 over 3, a positive 5 over 3 times negative 2. And I'm going to write over 1. And I write over 1 because really it's times negative 2, but I write over 1 because I know we're multiplying these fractions. So again, when we go multiply fraction, we go top to top, bottom to bottom. So 5 times 2x is 10x over 3. 3 times 1 is 3. Plus 5 times negative 2 is negative 10 over 3. And that equals positive 10. Yeah? Now, how do we get rid of the fractions? Do you remember? Multiplying by the common denominator. So what's the common denominator? Like this is a 1. But really it's just going to be, and what we taught you last year was do 3 times 3, which is 9. And 9 is a common denominator. It would work. But like, it's just 3. Yeah? Because like, why are we making our life difficult? So we're going to multiply this whole side of the equation by 3. And same with this whole side of the equation by 3. So we get something like 3 times 10x is 30x over 3 plus 3 times negative 10x, negative 30 over 3, and that equals positive 30. Now the reason why we multiply by the common denominator is because this is the magic that happens. These fractions reduce so perfectly. 30x divided by 3, 10x. Like literally, 30 divided by 3 is 10. So we got 10x plus negative 10 equals 30. Now that's not me rigging the questions up. Believe me, that's just math. That's just multiplying by the common denominator. Plus negative 10 looked a little weird, so I'm going to put brackets around there. And what happens is we just go back to our roots. Put the negative 10 over here. We get 10x equals 30. And 10x equals 40. Divide each side by 10. And x equals. Yeah? Now, that's my alarm. That's what I wake up to. I changed it from the other one. Okay, it's almost time. Now, I understand we're not quite done this, and I'm not worried at all in the slightest. Is something like this something that you'd see on a test or on that grade 9 review quiz? No. But kind of cool to review because it's been a long time. Yeah. We do have one more thing to do here, which is rearranging the equation into y equals mx plus b. Which you probably can already do. Yeah? Folks, remember this y equals mx plus b? When equations are in y equals mx plus b, life is kind of good, especially for someone who wants to graph the function. Notice how it's not 2y, not 4y, it's 1y equals mx plus b. Yeah? So this equation here, 2x plus 10y equals 20. Well, we wanted to kind of say y equals. So in order for it to say y equals, we're going to have to get rid of this 2x. It's actually going to go over here. Agreed? This is the equal sign. We're just left with a 10y. Now, a lot of us might want to do this. 20 minus 2x. And you know what? You're not necessarily wrong to do that because that's usually what you do. You put When you bring it over, it goes to the back end, right? Maybe? But because we're trying to go for this specific form, where the x variable would go first, you could just place it there, no problem. Now, it's not 10y, it's y. How do we get rid of the 10? Divide by 10? Okay, we're going to divide u by 10, and u by 10, and u by 10. And we get something like y equals 2 minus, 2 over 10? I know, it's gross. Reduce the fraction. 1 over 5x. Yeah, we can just divide that by 2, and divide that by 2. We just reduce the fraction. And that's so close to y equals mx plus b form. It's not quite there yet, because we got to put the x term first. So all we do is we just switch the spots. Negative 1 over 5x, and that's a positive 2. Now, some of you might say, Mr. Yakamisha, why did the signs not change? You moved the terms. I did move them, yes, but they did not cross the equal sign. Well, I mean, they did at the beginning, but not over here near the end. So that's why they don't change their sign. They haven't crossed the equal sign. But when they do cross the equal sign, yes, it'll certainly change its sign. Cool? Yeah, okay. Next one. 2x minus 10y equals 20. So same idea. We're going to get the y all alone. So we have, and this is where it's a little weird, because it says minus 10y. So when there's nothing in front of it to minus, it's now like negative 10y equals, and we're going to do this strategically. We're going to put the 2x, well, really the minus 2x first. And then that 20 is positive, so we can write plus 20. So now we saved ourselves a little bit of a step there, right? We just put the minus 2x in front, because we know at some point near the end, that's where that term belongs. And now to get rid of the negative 10, we're going to divide everything by negative 10. And this is where a calculator really comes in handy, because dividing by a negative number can lead to some minor errors. So negative 2 divided by negative 10, my calculator tells me 0.2, but I want that as a fraction. Actually says positive 0.2. I should really exaggerate positive. And then positive 1 over 5x. Positive 20 divided by negative 10 is negative 2. So minus 2. I've had some students in the past say plus negative 2. I say, okay, sure. Same idea, but really minus 2. Okay, and the last one here, it's so close to y equals mx plus b, except that we got this bracket business going on. So what we're going to do is just get rid of the bracket by distributing. So we should get y equals 2x plus 6 plus that 5. You see what I did? I did the distributive property in that one step, just went in my head, yeah? 2 times x, 2x, 2 times 3, 6, and then that plus 5, and I just came along here at the end. And we can tidy this up a little bit, 2x plus 11. And if you take a step back and look at this, it's in y equals mx plus b form. Lovely, okay. Folks, the grade 9 review stuff. Do you want to have some time tomorrow to work on it too? Let me know. Give me one of those or one of those. Yeah, you want to have some time tomorrow? The whole period tomorrow or no? Yeah, there are some of us in here that are like nearly completed, which is good. And if you're not there, that's totally fine. So how about we just agree and say, tomorrow will not be the grade 9 review quiz, right? And we'll just work on this stuff. Sound like a plan? This week has been very awful for timings of stuff, and I completely understand. So take some time, even tonight. Tomorrow we'll work on it in class, or maybe tomorrow, halfway through the class, you might just say, no, I want to write this thing, And if we all have a collective agreement, maybe we can write it. But if not, then I'm not pushing this on you, really. Okay? It'll be It'll be Friday then, yeah. Or maybe tomorrow, if there's a good chunk of us done, we'll just start unit 1, and the beginning of unit 1 is kind of slow anyway, yeah? We'll play it.